Okay, so let's try to solve this. This is a system design problem, and we are given a scenario where we are getting 5k sales and tech support calls every day on our platform. These calls are transcribed and stored, so we need not worry about transcription and storage. However, we want to know how they are stored, or like the format or DB schema. The idea is we want to provide the user a deep dive on these calls. Example questions are as follows: who is the most successful salesperson? What are their strategies? Okay, so there is who, which means we need some kind of NER, and then there is a most successful, which means it needs aggregation, as well as sentiment. Then what are their strategies is essentially analysis into so yeah, we'll come back to this part, how to analyze that. And then let's look at the second question: what is one major pain point? Okay, so one major pain point, aggregation. For pain point, it is some kind of clustering or classification. And then 80% of my customer complaints. 80% is once again aggregation analytics or something, and then customer complaint. So this is once again like some kind of cluster or classification. Next, most positively received features. This is some kind of sentiment or cluster or classify. And then we can also look at the feature is basically like NER. When I say NER, we can go more generic, but for now let's keep the feature as NER. How does it compare to my largest competitor? So now the largest competitor obviously has some kind of like stat plus analytics, and it also requires ingestion of external data. Okay, awesome. Next, critical bugs or issues in our system. So from the transcript we want to identify bugs or issues. So I would say NER, and then how do I come up with critical? So this is some kind of analytic. Okay, awesome. Okay, so now we know what kind of base operations we need for each question. Let's move forward. So there is no need to resolve IVE. Oh, that is a relief. This will require ingestion of current context, like real-time context. And assume the knowledge is monolithic and there is no access constraint. This is very good. So once again, like if there are access constraints, we will ingest these constraints the runtime when the user is asking a query. Data retention is 90. Any answer should look up 30 days unless explicitly stated. Wow. So once again, To support the unless explicitly stated part, we need aggregation slash analytics. Awesome. So available infra, we have PostgreSDB, very good. We have an embedding model hosted as a service, awesome. Then there is LLM gateway with support for all GPT models, great. Microservices fast API, nice, looks good, looks good, looks good. And the target is a cost optimal solution and UX is key. Okay, UX, we also have to look and target user experience, great. Super. And then we have a few axes, great, we'll come back to that. Now what I will do, we can start with the solution, I guess. Alright, so how does the workflow look? So a call is recorded, transcription service runs, stored, some PGDB, right? Let us assume that this is already given for us. Now we have to introduce all these NER or keyword extraction, then sentiment cluster slash classify aggregation, analytics. This can be batch actually or real time. We will come back to this later. Okay, so now NER and keyword extraction, like we can do parallelly itself. So as soon as we have the transcription, we can do this, right? Then sentiment also, we'll do it here. Oh, no tabs, huh? The good part is we can do everything like in parallel. Now for the clustering and classification and aggregation, we will need some rules or like some domain specific rules or downstream or downstream task specific rules, right? Without the rules, yeah, it's difficult. Coming to the aggregation, it is the same. So without knowing what to aggregate, we cannot aggregate, right? So we'll do it. Analytics also, okay. So now I'll write a call scheme, okay. So every call now contains list of keywords, boolean or enum, Okay, coming to the classification. So what kind of clustering are we looking for, and what kind of classifications are we looking for? So pain point, or yeah, the first thing is, like, we want to understand which type of call this is. So it can be either a sales call or a customer support call, which comes from, once again, this is enum, okay, and this is generated by an LLM. Going back, what is one major pain point? Okay, so we want to identify pain points, right? Then the positive part is already captured. So successful salesperson, success comes from sentiment. Salesperson comes from the call type aggregation. What are their strategies? So this is analysis. So yeah, let me write the types of analysis, because we can address this at runtime, but it is better to have an idea before. So let's add that sales strategy extraction. Okay. Then customer complaint will be in keywords, but keywords are more generic. We want a more controlled way of getting at it. So what can we extract? We are already extracting call type. So along with call type, we can have call type specific tags, right? For example, in a tech support call, we can have like a resolution related to bug, some resolution related calls, maybe some installation related calls. So we need subcategory in a call type. Okay. Not just subcategory, topics. We need topics inside call types. Okay, let's do topics. Topics will also be even. We can extend this so we can extend this like to list of strings for a more hands-off system, where topics will be derived based on a predefined generic rule, and then on top of these topics we can do the clustering and stuff. So yeah, let's make it like, anyway we want to do some aggregation and all. So let's make this a list of strings. Okay, great. What next? So there is NER. Oh, okay. So we have like NER and keyword extraction, so we can like use that in keywords only. All right, sentiment, cluster, classify, stats. How do we compare to my largest competitor? So there is a way to ingest external data, which means, and this external data will come from come at an organization level. So let us write org metadata, which will be a dict name. I hope the spelling is right. No, it's not. Let me fix it. Alright, so for now we have these things only. Okay, great. Can we continue working with this? Okay, so this is our target, and coming to the analytics, there is batched analytics or like real-time analytics, like says strategy extraction. Most fast feature. How does it compare to my largest competitor? Okay, great. Now how many of these can be done parallelly, like on, let's say, step 1? No, this is step 3, right? Okay, on step 3 we are also doing sentiment extraction. I think like step 4 can be done like on in async. As soon as some metrics are getting calculated, or as soon as the transcription comes, we can keep storing stuff on the like, PGDB. Then call type extraction. We have topic extraction. Then we can check and right, this is like a simple prompt which triggers a internet call and gets back to us. Okay, all right. So we have all of these. Now this is the workflow at index type. Okay, great. I will address the access soon, but this is done. Now this is the data schema. What happens at runtime? Okay, at runtime user query comes in. Now we want to extract the intent, and based on the intent we'll spawn a set of operations on our DB, and then we will aggregate with LLM. So this set of operations is not exact. I mean, this workflow looks like a RAG, but then the set of operations need not be a RAG, right? It need not be generic retrieval. There can be both retrieval and analytics, right? So there can be both retrieval and analytic tasks. Awesome. Once this is done at runtime, yeah, so let's expand on top of that. So step 1, query to embedding conversion. Step 2, now intent. This will be an LLM call. Okay, so at this point I think we will need some definitions, like some schemas to ground the entire thing and to standardize the entire thing. So intent operations, let's call it. Okay, so now what kind of data are we looking for? So we have NER or keyword. we can think of intent operation as like building a careful SQL statement which works on different types of tables, right? So NER, let's say there is a NER related operation, and the target will be a string, okay. Then there is a sentiment related operation which is like bool enum. Then we can have like a call type related operation which is once again grounded in enum. Then this is interesting, like there is a topic extraction, so topic names, let's call it, so list of strings, okay. And then what do we have? We have like check or data from the web. So I don't know, like here we can use some kind of like a filter which can not just filter, some kind of description for the LLM to do an operation which is not defined in the schema. This is where I want to fit the competitor. So what do we call that? Like, what do we call it? Analysis query. I know, like I'll refine this later. But these are the intent operations. Great. Now, identify intent is an LLM call. In step 3, for each intent, we have a I don't know, like some either SQL query or a workflow, like tool calling, like tools, something similar to tools but not exactly tools. Once the data so we run the workflows, and then using the extracted data we'll once again do an LLM call, and ideally we should get a solution by this time. But however, let's have a grounding step, okay. We can maybe add references right here, okay. So now with this entire like pipeline, how many of the like questions can we answer? For example, who is the most successful salesperson, okay. So for that, first thing, the call type will be sales call. Topic name will be, and we'll find some kind of topic name like successful sale or sale closing or something. Then the sentiment will be positive. The analysis query will be extract the salesperson with most number of positive calls, like something related to that. Given that we are, at least now, until now, we are not storing the humans alongside like the human metadata. We should have stored that if the data is available, we should have done that. But given that we are not doing it until now, it is on. It is now the LLM's responsibility to get the output. Okay. Now, what are the strategies? Once again, like there is like topic names. Using these topic names, LLM can identify safe strategy. Also, here we can introduce like domain knowledge, which is like very important for successful LLM applications on like what kind of strategies might be presented, right? So let me write this. So we can ingest strategy list, like predefined strategy list. So if we do this, there will be one more. Say strategy extraction, and then there will be one more. Which will be an optional enum, and then in the intent we'll have okay. So the key thing to note is as we keep increasing these like predefined filters or like predefined metadata, the number of LLM operations will increase. We need not increase the number of operations, but the token counts or like the token usage will definitely increase, as well as latency will increase. If we are combining multiple LLM calls or like multiple extractions into a single LLM call, the quality might take a dip, right? And then coming to the like the retrieval part, we have to be like careful on how we do this intent operation, or like how we approach the spawning, right? So how do we identify what to spawn? As the number of predefined these things increase, the set of operations also will increase. Even though we can do multiple operations in parallel, in the end there will be more LLM calls and there is more scope to fail for quality to dip and so on, right? Now going back, what else do we have? So for example, pain point. Let's also add pain points to this. So these specific things, let's say strategy and pain point, they can be part of as soon as the call type is done, we can do this. Okay, so and then like so these are call type specific metadata. Should we consider this field or not? Okay, so for now I'm not diving deep on each of these axes, but this is the system which can work. This system can work, yeah. Great.